Okay, I've recorded a lot, and I realized I accidentally changed the scene, so that's my bad. So I'm gonna break down what I did basically. So I went to your data. Your data was kind of confusing me, so I just went to the raw data. Um, and I'm just doing this for an example. So I did all drug deaths because that seems like a good dependent variable. Total funding. What I did was I just ran a ifs formula. And what I did was if the year equaled 2020, then it got X amount of funding. So, it got, that amount of funding. And so as you see, it just lines up. So now we have that as a variable. You have all your drug deaths, which is your Y, your dependent variable. Funding is one of your independent variables. Now let's look at our data and let's see. Okay, number of drug overdose deaths amongst persons who are experiencing homelessness or housing instability. That is a good independent variable. So we'll find that here, homeless deaths. All right, where are you at? Where are you at? Homeless deaths. Let's copy this. So out of 171, 12 of them were homeless. Okay. Okay, let's see. Maybe we'll do this. Number of people getting treated for pain. Current pain. Copy. Paste. All right. So let's try to run a regression here. We haven't done any variables yet. We can do that. Actually, you know what? Let's see if we can throw one in here. Let's look at. I'm not gonna worry about variables right now because it seems like they already have all the variables spread out. So I don't even know if you need to do any. What we're gonna do is we're gonna run a quick regression model. So through Excel, you're able to do this. If you go to File, so you click File up here, Options down here. You'll go to Add-ins right here, Excel add-ins. Make sure it's Excel add-ins, and then Analysis Toolpack. You want to check those two. You'll hit OK. Then you'll go up to your data box. You'll have Data Analysis right here. You're going to want to scroll down to Regression, as we have here. I'll hit OK. Our Y, our dependent variable, is all drug deaths. We're going to go ahead and get all those. Our independent variables are going to be the total funding, homeless deaths, if they are on pain, they are male or female. Click labels because we're including labels in this. And I'm just going to have it work a new worksheet. We're going to do a. All right, here we go. So now we have our regression statistics. This is a linear regression model. So let's look over here. Let's kind of see based on this data. So typically, when we run a regression model, we want to see a 95% confidence. And that means our p-value should be less than, oh shoot, our p-value should be less than 0.05. So our null hypothesis would be that there is no significant relationship between our independent variables and all the deaths, which is our dependent, if that's what you're looking for. And we'll reject that null hypothesis if our p-value is less than the 0.05, because that's 5%, which is within our confidence interval. So basically, there's a significant relationship if your p-value is under 0.05. So we're gonna go and we're gonna look over here. So first we have our total funding. So for every 1 unit increase in total funding, we had -2 in all deaths. Well, that sounds nice, but let's look at our p-value here. And our p-value shows us that it is way above 0.05. So this is not a significant relationship here. So this is not reliable. It is not, you can't really trust this. So now let's kind of go down here. Our intercepts, like our constant, whatever. Homeless deaths. Now this is a big, huge significance here. For every, one person that's homeless or whatever, all deaths increase 0.75, whatever. Anyways, this, that comes out to like 0.000, 11 zeros and then 2, or like 10 zeros and then 2. So that is well below 0.05. So this would be a significant relationship here. So that is significant based on our regression accounting for these. Now we look down here. All right. This E minus basically means that the decimal point goes left. Well, we see here that is also going to be way below 0.05. And when we look at our significance, that is way below 0.05 as a whole. So this is a significant regression model. And homeless deaths and female deaths are significant, basically. This is what it's saying. These are not, but these two are. So there's a significant. So you would reject the p-value here because one or more of these are significant when it comes to influencing all deaths. And which ones are they? They're homeless and they're female deaths. That's my understanding. And there's your p-value. Here's your test statistic. Here's your F statistic for the whole thing. So that's my understanding, kind of. That's how I would do it. I don't know if that's necessarily right or not. Now let's see if we can do the same thing using SPS. So we have our SPS here. And go to data view. Alright, I'm going to go to my data that I have with all my stuff, my variables and dependent variables. I'm going to take it here. And I'm just going to copy I'm going to paste with variable names. That's important because it puts your names up here as headers. So we have all of our stuff in here now. Here's all of our data. We can maximize this now so we can see. Or if I can zoom out a little bit. No? Okay. Whatever. We have all of our stuff. Total funding, blah, blah, blah. Male deaths, female deaths. If they're on pain. Okay, all that good stuff. Here we go. So, we have our stuff. It's already numerical. It's all numerical data. We're going to want to analyze. We're going to go down to regression. We're going to do a linear regression model. And this is what is going to pop up on your screen. So all your drug deaths or your opioid deaths or whatever you're doing is going to be your dependent variable. Click that, it'll put in there. And then your independent variables are going to be your total funding, your homeless, your on current painkillers, your males, your females, all that good stuff. So your Y variable goes in the dependent, your X variables go in your independents. So now, look at statistics. I clicked on statistics here. Estimates. It's all good. Plots. It's alright. Alright, so I think we're ready. We're going to hit OK. Alright, now where'd it go here? Okay, hold on. I haven't used this in a while. Okay, sorry. Here's our regression. So, this is going to give us our variables that we entered. It's just a list of what we ran the regression of. Model summary. So here's your R squared, adjusted R, standard error, your ANOVA table. This is our F statistic, basically of the whole graph. The significance, under 0.01, it's under 0.001, so, this shows that it is very significant. There is a significant relation. We go down here to our graph. And we have our variables here. Here's that constant, our intercept. Here's our funding, homeless, current male and female deaths. Our dependent variable is listed as our all drug deaths, like we did. We have our test statistic for each one here. And here is our p-value right here as our significance. And if we look, we'll see again, over 0.05. Our homeless, again, is significant, under 0.001. And we have our females, which are also under 0.001. So these two are significant. And so what we'll want to do here, kind of minimize this. We'll bring this, I'll just delete this. It's okay. I'll just create a new sheet here. Sure, we'll copy all this. Copy, paste. We can just copy all this and paste it over to our Excel document. All right. So now if we go back to our Excel document here, let's zoom out a little bit. This is pretty ugly, but what I want you to see is that if we look here, we've ran our linear regression model, and we've gotten our answers here. And if we look, let's compare these side by side here. Kind of just gonna delete that now. But if we look here and we put them side by side, we have the same outcome. You have your coefficient right here, 68.341, 68.341. You have your standard error. You have your test statistic, and then your p-value significance, These are just your kind of confidence interval, lower 95%, over. So that, we don't really have to worry about that. You won't use that. And then, same here, under 0.001. This is going to be under 0.001 when we account for this here. Basically means that the decimal goes left that many times. Our F statistic, all this stuff, sum of squares, degrees of freedom, your R square, is 1 away from 100, I think is what that means. And 99, this means our statistic is 99% accurate or whatever, basically like that. Standard error is 125, standard error 125. So you can see. Voila, so that's, 2 ways to run a linear regression model, one through Excel and one through IBM SS.